Hey, here we are taking a look at what we're going to be working on today. We are going to be making these three items. Really, it's more like two items. You'll see why as we get into it a bit more. But we are making this propeller that is going to be our turbine, and then taking a look down at these gears, these bevel gears, that are going to translate the motion of that turbine, rotate it 90 degrees, and send it up to the little motor that we're going to use as a generator to get a little bit of current, and then we're going to use that to calculate the flow rate of our stream. So this is where we're going. Why don't we get started? All right, so here we are in Inventor, and this is sort of where it should load out for you when you first start up. Over here, we've got our list of projects. As you can see, I haven't done much with Inventor since I reinstalled it on this computer. Over here, we've got some options for creating new stuff. Down here, this sort of recent documents tab is empty because it's a new project. And I've already created a project, but why don't we go ahead and walk through how to create a new project, just to sort of get us off the ground with a good start. So we go up here, top left zone, to projects, and we hit down at the bottom, new single user project. Vault projects are a way to collaborate that I have so far not seen too many people using. I think people that could make use of those tend to use other programs. Not going to say anything else because Autodesk will come after me. And here, once we hit next, we get to, all right, where is this going to save? And I let it save to the default location. You could change this, right? You can browse, pick a new location, and you're going to name the project, right? And this is the point where I'm going to sort of abandon you. But when you hit next, it's then going to give you the option of the path does not exist. Do you want to create the path? And you're going to say yes. All that's saying is, hey, this folder, right? We've got the folder listed here. It doesn't exist yet. Should we create it for you? And the answer is, of course, yes. You need somewhere for that to save. We're going to hit cancel right now, though, because I've already created this guy. So we can close out of this. And you'll see it is empty. I started some stuff and then realized I wanted to record what I was doing. So I have deleted what I started. We want to, of course, start, as we almost always do in Inventor, with a part. Now we can do new part, but then we'll have to go through the hassle of changing its units. I prefer to start with new from up here. And you'll see I've already got it set to metric. It's going to be here on English because it wants you to work in inches for reasons that escape me. I want to work in millimeters. My 3D printer and the 3D printer at our makerspace both do everything in millimeters. The layer heights are in millimeters. The bed dimensions are in millimeters. The speed is in millimeters. So we're going to work in millimeters. And that's purely to make life easier for me. So create millimeter, that .ipt, that's the Inventor part. And here we are, the lovely blank blue screen of Inventor. So let's take a look at the thing we are going to be modeling, a propeller. Now, this is not the correct thing to use when trying to make a generator. We're going to do it anyway because I don't know how to design a turbine because I am an electrical engineering student. I'm not a mechanical engineer. I'm not a mechanical engineering student. I don't understand flow dynamics or fluid dynamics or any of that. And frankly, for what we're doing, for making a little sensor out of a turbine, it shouldn't matter too much. We're not trying to optimize this. We just want a thing that we can measure. So let's take a look at our geometry here. We have sort of in Inventor thinking, we've got two parts. We've got this central cylinder, and then we've got the blades coming off. And you might say, well, Josh, that's 4 parts, right? There are 3 blades. In Inventor thinking, though, I'm looking at this and I'm thinking, these are identical blades. I'm going to make one of them, and then I'm going to make a circular pattern to get the others. So it is one blade that I've patterned around. And as we look at this, the central piece, if you've played around in Inventor, is something that you should be pretty confident making something at least close to it, right? We're not going to get the exact dimensions. That's fine. This is just sort of a generic reference image. You're like, all right, I'm going to extrude a circle. Maybe I'll add a fillet or a chamfer up here. I'll extrude in a bit. You know, this is all extrusions. I'm making a bunch of circles, and then I'm using the extrude tool. Maybe I'll get fancy. Maybe I'll loft something, right? And then, okay, well, maybe we do an emboss to get some sort of logo. Spoiler alert, I will not be doing the emboss. That is not a necessary piece of this. But then how on earth are we going to make these blades, right? They are a very funky shape. And as I look at them, I sort of see here, as I trace along this line, that this is a bit like a spiral going up, right? And we've got sort of a smaller spiral on the inside and a bigger spiral on the outside. And then we've cut out the shape from that, right? If you can imagine taking a sheet of metal and twisting it, and then cutting out the shape from that twisted piece of metal. And that is exactly what we are going to do in Inventor. And you might say, all right, how on earth are you going to do that? That's not a thing we can extrude. You are correct. We are going to do this with something called surfaces. They are a very powerful tool. I will not pretend to be an expert in them, but I am okay enough to get this effect. So let's get started. So we go back to Inventor, and the first thing I want to point out is up here we've got our surface area, and it's got all sorts of really cool stuff that we can do to sculpt and patch and stitch surfaces, and we're not going to use any of it. We don't need it because everything we need is built into our normal solids tools. And like we would with any solid, we are going to start with a sketch. So start a 2D sketch. I'm going to pick the I want the XY plane. I do want to use the XY plane. I like looking at things from the front in the view cube. And as I think about this, I've sort of worked out a little bit of, not the math, like I haven't done the engineering calculations because, as I said, I don't know them. But I've sort of worked out the geometry ahead of time a little bit. So I know that I am going to need a line that I'm going to orbit about, right? This is going to be my axis. This is the center of my propeller. And then offset from this a certain distance, which we will add the distance later, we're going to have our inner spiral, right? And so our inner spiral is going to start down here at this green point that I'm hovering over. And it's going to be offset by a distance of this line. And we're going to deal with that right now. We're going to set this guy up, and we're going to pick a dimension. Now, I don't really know the exact numbers that I should be using here, so I am going to make something up. And I happen to like using even numbers whenever possible. Odd preference, but I prefer it. And so we're going to go with 14. And you know what? 14 is bothering me. I like to do multiples of 4. So we're going to do 16 instead. Completely arbitrary. We might look at the final product and say, you know what? That's too big, too small. And we can come back in and mess with this, right? The beauty of Inventor is that this is a parametric modeling software. If we come back in and change this, it will sort of cascade through everything else later. Now, it might break things. That happens. If you change your numbers too much, it might break stuff. But we can always fix it. And now we need this guy. And again, I like my multiples of 4. We're going to go with 8. So what's happening here in sort of my planning is we're going to start our spiral down here, and it's going to spiral up, and it's going to come up another 8 millimeters, right? So it's going to come up that much. And now we're going to need our outer edge of this. And now I'm going to base this off of, so let's draw our line. Same exact deal, right? And we want that guy. I'm going to base this one off of, technically I don't actually need that other line. So our 3D printer can fit about 150 millimeters across. I know I'm going to need some wiggle room for some other pieces that I'm going to add on later. So let's go ahead, 140 millimeters, divide it by 2 for a nice 70 millimeters. We could mess with this, get it to be a multiple of 4, but that's not an OCD thing for me. I don't care that much. It's a mild preference, not a compulsion. So 70. And you can see this has immediately moved over. I don't like that it's done that. This should be my center line. So let us do a couple of things here. One, let's go and just make this guy coincident with the origin. There we go. That's how I want that to look. And now everything should be locked down. You can see how all the lines are black. This one isn't all the way locked down yet, but right, if I try to drag anything, it won't drag. Except for this guy, I can drag out. And so now, let's go ahead and set this. And again, this is my height that this is going to be, right? We're going to start 24 millimeters down, we're going to extrude up. 24 millimeters, that is about an inch, a little bit less than an inch. So there's that. That's the start of this. And now you might say, looking at this, great, Josh, you've got points. Inventor generally does not do anything with points. You need a profile. And sort of to give us a definition, there will be a quiz later. A profile is a closed geometry, right? So if I do this, that did not close properly, and I can tell it didn't close because I didn't light up green. So see how that point lights up green? That means that I'm latched on. I've got sort of my snap on. And there we go. There's my green snap. So I've got this now. This is the geometry that we are going to coil up to make our spiral. And you'll notice that I've made it as a triangle so that I'm going to get a nice line. Not really a line, I suppose, but a single path that is in the spot I want it to be. That's why I've done a triangle at this point. I could have done some other thing, right? I could have made an ice cream cone. I could have done a square, a diamond, whatever. So long as I had a point here, it would have worked. And we're going to do the same over here. And now, just to get us some practice with dimensioning. So before we did dimensions of these guys, and I think I forgot to say it. I believe I used the D key to get dimension. So I pressed D, and then it lit up, and I was able to do stuff like that, right? What we can also do is we can click dimension up here. This is our constraints toolbar. And so what we did before is we have general dimension, and then we also have, I think I used the coincident constraint, which just says that these two things are going to touch each other. We've got a bunch of other ones. They're all very useful. In particular, right now, we're going to practice using the equal constraint because I want these to be equilateral triangles. No functional reason for that, just a preference. So, all right, these are both equilateral triangles, and now let's make them the same. So, right, I've applied an extra, so I've made this side is equal to this side is equal to this side. That's our equilateral. I've done the same with this triangle. And then I've set one of the sides from each triangle equal to each other. And now we can do some fun stuff, like if I were to scale up either triangle, the other one would scale. Let's go ahead and set a dimension. I've again used the D key to pull up dimension. You can see as I hover over, that's green. It's got the arrows. And let's make this 2 millimeters. Again, no functional reason. These triangles are not part of our final geometry. But just to be neat about things, everything is now fully constrained. We can hit Finish Sketch. Now, some of you might be a little bit more experienced with Inventor, and you might be saying, Josh, you've made one sketch with a bunch of geometry, and you're clearly going to reuse this geometry. Yeah, no, that's not how people normally do things in Inventor. I will confess I come from using Autodesk Fusion. I like to have one sketch that has a lot of my master dimensions in it. It is not good practice, but it is what I do. And I'm running this video, so you got to watch me do it. All right. So we are going to go up here, and we're going to look at these tools, right? We have extrude, straight line, not useful. Revolve could be useful, but not quite what we're looking for, right? If we do revolve, let's do that as an example. We go down here, we grab this profile, we grab this axis, and we get this sort of triangular donut. Not what we're looking for. We want a spiral. What we actually want here, we could do something with sweep, right? We could make a path, but if we did that, then we already have the path. It's a lot of trouble. Don't want to deal with it. We want coil. We'll come back to loft in a little here. So coil. Coil creates a spiral. And first thing we're going to do, we're going to select our profile. So select profile, this fellow right here. We're going to select our axis, this guy right here. We have some methods. I like revolution and height for this. For some reason, it insists on being in inches. That is not what I want. I want it in millimeters. And millimeters should be our default. And we'll be able to check that in a little. And you'll be able to see now, as we look at this from the right, this is going the wrong direction. And so we'll go up here, and we will hit reverse pitch direction along axis. And now it's going up. And you can see that that is how I want that to be. I'm using my view cube over here. I will hit home now, which is usually where I go to. And so there we go. That's our first piece. We're going to hit OK. And we now have this part of a spiral coming up. Now, you may have noticed, the astute among you will have seen, that that sketch where I put everything I need has disappeared. So what we're going to do is we're going to come over here to our model browser, and we're going to right-click the sketch, and we're going to come down to Share Sketch. So we now have here, and you can see it's been denoted that it is a shared sketch. So it's back. It is back, baby. So we're going to do the same thing. Same exact process. I'm going to zoom through it a little bit more. Grab this guy, grab the axis. It's going the wrong way again. And this time we want to go 48 millimeters. And I'm getting these numbers. Double check. It's unflipped itself again. There we go. I'm getting these numbers by doubling my offsets, right? I want this line to be sort of on the horizontal midplane. And we want this to be a new solid. All right. So now we have these two guys. And they, you'll notice they do not look a lot like a propeller. Don't worry, they will. So we're going to leave this sketch in the background as sort of a thing that we can deal with. Now let's take a look at loft. Now, loft is interesting in Inventor. It's actually got two different modes, and I think most people will use it in solid mode, but we're going to use it in surface mode. And for surface, so for solid mode, I would need to be like, I want this surface, and I'm going to loft it over to like this surface, and it's going to, well, we can actually, let's take a look at what that looks like. It creates this thing, which is actually not too far off of what we're going to end up with, but it's not quite right, so we're going to get rid of it. I just hit Control-Z, by the way, to undo. So, surface. For a surface, we get to pick a line. And then we get to pick another line. It's going to be finicky. You'll notice it's not lighting up. We actually need to go over here and click to add. And there we go. And we're going to hit OK. And now we get this orange thing. And it looks a lot like one of our sketch planes, except that it is curved. And to better see it, let's go ahead. We no longer need our triangular cross-section, whatever they were. So let's go and turn off visibility. And you can see now that is the profile for our propeller. So, all right, here it is. It's sort of the math surface, right? It's a infinite plane of infinite thinness. It is completely useless as a thing that we're going to 3D print, right? 3D printers need a solid object. So now we're going to go ahead and we're going to go over to modify, right? And here we've got thicken/offset. And what we're going to do is that we're just going to go and treat this like a face that we're going to thicken. We're going to select that. And we can do inside, we can do outside, we can do center. I like center because, again, it's just easier. And what this is going to do is it's going to make a 1 millimeter thick solid that is coming off of this guy. We're going to do a new solid. Again, we've got these Boolean operators here. We can join, we can cut, we can intersect. In this case, we're going to do new solid. We'll see how I feel about this. I might decide I want this to be 2 millimeters later. Generally leave this advanced property on. We can sort of orbit around, see a little bit of a preview. So let's go and hit OK. And aha, now we have a solid. And again, we had this sort of intermediate geometry, this surface. We do not need this surface anymore. So we are going to turn off the visibility on that. It's still there if we change our mind later. All right, so we've got this guy now. And what I really want is I immediately want to turn this into, instead of like, I don't know, like a lady's fan from the 1800s, instead I would like this to be a propeller blade. And so we're going to do some more typical stuff here. We're going to make a sketch, and we're going to intersect that sketch with this to cut out our shape. So where do we want this sketch, right? We want to do a sketch, and we say sketch, start 2D sketch, and we've got not a lot to work with, right? We've got our origin planes, but they're not really in useful spots. So we're actually going to start by making a new plane in a more useful orientation. We have a few options, and I'm going to pick the 3 points. And the 3 points that I'm going to pick are the tip of, no, you know what, we're going to do it this way. The tip here, right? The tip up here, and then our center point. And so this has created a plane that is pretty similar to the plane. Our propeller isn't on a flat plane, but if it were, it would kind of be on this plane, right? That's what I've gone for here. And this is where I'm going to do my sketch. And this is just to give us less distortion. So here's our sketch. Here is our object. You'll notice as I try to draw things that I don't latch on to anything, right? I like my green dots. I like projected lines. So we need to get this geometry onto our sketch, and we're going to do that with project geometry. There's a few different options here. In this case, because we're not cutting perfectly through, we are going to do just the regular project geometry. We will select this guy, and that'll be that. That's him there. And now we can turn off some visibility. We don't need that guy to be visible. We don't need this guy to be visible. We can bring them back later when we need them. And what we want is we want to go ahead and create an arc. And we're going to just do this guy here. All right. Now this arc looks pretty arbitrary. That is because it is. But we're going to give it some constraints again. So we go up to constraints, and we've got this guy here, tangent. And what I really want is I want to be tangent everywhere. And that is going to be our propeller blade. You'll notice that we've lost some surface area. That's OK. We can go ahead and hit Finish Sketch. And now we will bring this solid back. So turn its visibility back on. And we'll turn this this plane off. We don't need this plane anymore. I like to keep my view screen clear of stuff I don't need. So we're going to hit Extrude. And we can't really see our sketch, but Inventor is sort of smart enough to know, right, that we've got limited options of what to extrude. It's going to be one of these three things. We could do a cut with these guys. We might lose some areas if we do that. So instead, we're going to go with this guy. And when we look at our Boolean operators, we can join, we can cut, or we can intersect. And that is the one we want right now. And when we go up to our direction, we are sort of living in the middle of this guy. So we want to go symmetric. We don't really care about the distance. We're going to be limited in distance of what appears by the fact that we're intersecting, right? We're saying what exists in both places. So we hit OK. And now here is our propeller blade. Glorious, isn't it? Not particularly, you say. So what else do we need? We go back to our image of a propeller, and we see we are missing a key piece, the center. So let's go back to Inventor, and let's do our 2D sketch. And let's do this one, right? This one is going to work fairly well on the XZ plane, right, from straight above. And conveniently, that brings back the origin, which is what we want. And we're going to come out here, and let's go to 30. Let's type correctly and do 32 millimeters out. That matches to exactly what our inside is. I think I want a little bit more overlap than that. So let's go ahead and buffer this out to 36 millimeters. And let's go with that. So that's it. That's this sketch. We can be a little fancy. I know that we're going to want to mount this onto a spindle, onto sort of a central rod. That central rod is 2 millimeters. Let us go ahead and give ourselves a little wiggle room on it. Let's do a 2.3 millimeter hole in the middle, and then we'll trust glue in the center. So finish sketch. And now we'll hit extrude. So as we look at this, we are going to do symmetric. We can pull this guy up and down, and we've got some options here. Let's see what happens, because I haven't played with this. If we do 2, this bottom, all right, it doesn't like that. So instead, we are going to stop that, symmetric, and let's go with 32 millimeters, and enter. And now that I think about it, that's not quite how I wanted that guy to go. Let's edit this guy, right? This is a parametric software. We can go and we can change stuff. So edit this feature. There's one thing I forgot. I don't want to join these yet. We can do that later, right? So I want this as a new solid. And now we hit OK. So here we go. That's our central piece. It's got this this hole in it already set up. And you'll notice that, again, these are now two separate bodies, right? We can turn them on and off individually. This is important because we have one more important step. Remember I said it's really only two parts. It's our central sort of chassis, fuselage, I don't know what to call it. And then it's the blades. And I'm calling the blades one part because we're going to do this. We're going to come up here to pattern, and we're going to say circular pattern. And it's going to say, what features do you want, and what's your rotation axis? And you can pattern individual features, which isn't really useful to us now. It took us a lot of steps to get to this guy. Instead, we're going to do pattern solids. And now we can just select either of these, and obviously we want the blade. And then we're going to select our axis of rotation. And the nice thing is we can select a line, right? We could go in here and we could pick the y-axis. But also, if you pick a cylinder, Inventor is smart enough to say, you mean about the center of that cylinder. So we will do that. It says, how many do you want? We want 3. And we do want them to go the full 360 degrees. We could do something funky here where you do fixed, and you can sort of see the outline of what that would look like. Obviously, that is wrong in this case, but it might be useful to you at some point. But we want to let it rotate. And there we go. That is a pretty passable looking boat propeller. All right. So with that, I've been risky. It's been about half an hour and I haven't saved. So let's go ahead and save right now. And you'll notice it is automatically saving in turbine. And we will call this prop for propeller and save. All right, so here's this guy. I'm actually fairly happy with how this has turned out. And we'll see, we haven't tested it yet. We might test it and find that this is absolute garbage. We'll find out. But now, as I might have mentioned, we want this to turn a gear, right? We're going to have sort of a flow of water. And let me actually just do this in a sketch to sort of show you what's going to happen. Is as we, if we have our flow of water is going to go that way, right? Along this line. Right? And it's going to spin around this central axis, right? And so we're going to need to do some translating of that. So all right, let's close out of this sketch. We don't need this sketch. Not a useful sketch. So we've got this guy, and it's going to spin. And that's all fine and dandy, but we need something for it to turn now. So this is where we're actually going to do something a little bit unconventional. Inventor has a way to make gears. Has it built in, ready to go. It exists only in the assembly. So we are going to do File, we are going to do New, and we are going to do a new assembly. And it is almost certainly, because again, I haven't messed with everything that I should have, going to have us in inches, which is annoying. Yeah, it is. It is in inches. I know it is. That's fine. So we're going to go to Design, and here we've got what we need. We've got some interesting things here that I don't play with much, but what I want is I want the gears. Now, I don't want a spur gear. What I want is a bevel gear. And I must save the assembly before creating a design accelerator component. Yes, I would like to save the assembly. We're going to call this propeller, I cannot spell, propeller assembly. Don't be imaginative with your names. You want to look at it and say, that's called propeller assembly. It must be the assembly of the propeller. So we get this whole thing. And this is another spot where we remind you that I am not a mechanical engineer. I'm an electrical engineering student. I vaguely know that I would like, and it is in inches. That's annoying of it. All right. I know that I want a 2-to-1 gear ratio. So we're going to do that down here. And we can do calculate, and it'll update some stuff for us. Tool tooth tip is truncated. That we can mess with. Right, we got a bunch of things to mess with that I will be entirely honest, I don't understand. And so we're just going to mess with stuff until it looks right. Tool tooth tip is truncated. Yep, that's fine. We should have a modulus somewhere. Why do we not have modulus? Okay. Face width, that's actually about what I want. 10 units per inch. Maybe that's our issue. Let's go and up U. See what happens if we up U. Calculate. Ah, there we go. So we are getting somewhere with this. All right. 0.894. Unit correction, tangential replacement, shaft angle. Yeah, that's fine. Just, you know, I am literally just sort of figuring this out as I go. This is very much a case of I'm going to mess with this until I like the numbers it gives me. So let's keep messing around. There are tutorials on how to use this tool, but I'm lazy. I will be entirely honest with you. That's what's happening here. All right, so our face width isn't changing, and that's because there should be a thing somewhere on here that says modulus, and it doesn't give me that. All right, let's go back down to 5. Calculate. Okay. Accept the automatic edits. The computer knows more than I do, and that's just a good thing to remember. All right. So let's see. Here's these guys, and I want, and you'll see what I'm doing in a little bit, I want to see what's going on here. Perimeter is very much not what I want it to be. That is a fascinating number it's giving me, of 49-inch perimeter. That is not what I want at all. Ideally, I should be getting somewhere around a perimeter of 3.14, because that means that I will have a diameter of about 1 inch. So what we can do, again, this is parametric software, is I can go in and we can go into this guy, edit using Design Accelerator. So the question becomes, is face width my issue or is diametral pitch my issue? Let's try changing face width. Accept the edits, and watch to see what happens. So face width is not my issue. It's done something very funky when I changed face width. Let's undo that. Edit using design. And actually, I kind of want this face width to be bigger, I think. Yeah, let's bump you up to a whole inch. So diametral pitch is probably my issue. Let's try bumping you up to 20. Tool 2, yeah, that's fine. Accept the edits. There we go. That's the one I wanted. And so you see that got a lot smaller. And so now we can go up here to our tools to inspect, to measure. 12.398 inch perimeter. That is looking a lot better, but not quite what I want yet. We want this even smaller. And we may have to do some changes here to, yeah. Let's go ahead and drop our teeth numbers, our tooth count. And that's that. Yeah, I like that pressure angle. It's fine, because I don't know what I'm doing again. So, cancel. Calculate. Calculation indicates design failure. So it doesn't like the number of teeth I've added. Ah, that was too big. So we're going to keep messing with this because obviously I want as big of a number here as possible. 17. Calculate. There we go. Okay. Accept the edits. Here we go. Let's see how that does for us. All right, so this is about 2 inches in diameter. Let's see how this looks now. So this is an assembly, and obviously we should be putting things into it. And we're going to do so. We're going to hit place, prop, open. Now, this is not ideal, right? I would have liked this guy to be a bit smaller. So let's actually mess with the bevel gear a bit more. Edit using design accelerator. Let's try dropping this down. Now, I recall vaguely that there's like a minimum number of teeth that you can have for a gear to be effective. Let's see what happens as we drop down a bit. Calculate, still no good. 15. How do you feel about 14? 13? There we go, 13. Okay, accept the edits. All right, we might be just hitting sort of the minimum amount here. So that is fine. We are going to mess with things a little bit in this case, right? See, I don't know much about flow dynamics, but I know that when we have this guy mounted onto here, we're going to hit this flat surface and it's gonna get funky. And I don't want it to get funky. So we are going to go in. Now the important thing is these each have had an Inventor part created. So we're actually going to hit save, yes to all, okay. And what we want to do is we want to actually go in and edit this gear as an individual part. So we're going to do that. We're going to hit edit. It opens it up on it inside the assembly. And when we want to go back to the assembly, we can hit return. And we can sort of zoom in and look at this bevel gear. And what I would really like for this to do is I would like it to taper up a bit, right? So what we are going to do is we are going to create an offset plane. Offset from plane. Offset from here. Let's go up. Oh, let's do 2 inches. That looks a bit much. And again, we can mess with things to a certain extent. Plane doesn't like to be messed with. Offset plane, let's do 1.5 inches. Again, we've switched from millimeters into inches out of sheer laziness. I will, again, be frank with you on that. And now we can do a sketch up here. And so I want a smaller amount here. I'm not sure exactly what, because I don't remember what I did. So let's go back. Let's take a look at this extrusion. And as we hover over it, we can actually see the numbers, but let's edit sketch. 36 millimeters. That is our target number. So we can close out of that, go over here. And we're going to do the same thing. We're going to put at the center here, and we should be able to say 36 millimeters and just sort of force it to be in. And you can see it's given us a number in inches, but that's after we forced it to be millimeters, right? And that should be centered. Yep, looks like that is correctly centered. Finish sketch. And now we're going to do the other version of Loft. Before we used Loft to create a surface, but we can use it for a solid. And when we do that, we will click this, and it's being a little bit annoying to get that surface. There we go, that surface. And then we will click to add to that guy. And we will hit OK. And now we have this lovely new solid. This work plane can go away. We don't need it. And that is actually looks quite good. So we can now hit return. Not quite. We don't quite want to return. I forgot one other key piece. Remember that hole that we put? We need to put a hole in this guy because our shaft will have to run through both of them. And again, we're going to force this to be in millimeters. So 2.3 millimeters. Done. Finish sketch. And we're going to go up here. We're going to do extrude. And we're going to say cut. And it's going to automatically reverse directions. And then we're going to hit, instead of 2 or a number, we're just going to say through all. And that means we're going to go all the way through. Hit OK. So that's that guy. Now, we've got a couple of options when we make this. One is that we can print these two as a single piece, and the other is that we can print them separately. And I suspect that we will get more bang for our buck printing them separately. I think that we're going to be gluing things onto our central shaft anyway. And this way we have sort of less chance of massive failure. So here we are, we've got these parts. We are going to need to put a hole in this guy, but that we can do later. Yeah, this is our propeller and the gear that will go with it. And there's not a lot else to say. Next time we will look at how we actually set these up to 3D print. But yeah, hopefully that is helpful. Hey, so I realized after ending that recording that there were still two things that I wanted to do. The little bit that I know about propeller design tells me that actually for a turbine and for some stability, we want a sort of retaining ring around the outside, and then also we want to not have a flat surface here. And I remembered it down when we were talking about this guy, but we want to sort of minimize our turbulence. So let's go back to our propeller. And let's take a look at this guy. So we've got two things that we still want to do. We want to make a retaining circle, and we want to make sort of a nose cone. So let's start with the retaining circle. We're going to start that over here. And this is going to be pretty quick and dirty. We're going to hit circle. We want that to be centered on the center. And we're sort of just going to eyeball this guy in, right? The very advanced design technique of, all right, taking a look at this and saying, all right, 136 millimeters. There we go. And then we're going to offset this guy. And we're going to offset him 2 millimeters, which looks like it is going to capture everything. We'll see if it doesn't. We'll go back in and modify it. And we're just going to finish sketch. That's all there is to that guy. We can now extrude up here. And we're going to make sure to only grab this outer ring. So we've got sort of a bunch of stuff we want just that outer ring. And we're now going to use something that we haven't actually used before, which is 2. And we're going to go 2 here. And we're going to make sure that we are using the Boolean operator to join. And hit OK. So there's our retaining ring around this guy. And now let's go ahead and let's talk about our nose cone. There's a few different ways that we could do the nose cone. I'm a big fan of the revolve tool. And so that is what we are going to use. We're going to start this sketch. And we want the plane that bisects our propeller. And that's going to be our XY plane. And as you can see, we have some issues with our geometry. We'll fix that in a second. So right now, we can't really see what we're doing. So we are going to do project geometry. And before we did project geometry up here, in this case, we want the cut edges. So we're going to do project cut edges. And that is going to give us all of those. And we can now turn off visibility for our solids for a bit. So we can see here is that central shaft. Ignore all this nonsense. This is our propellers. Here is the central shaft. Here's our edge corners. So we are going to start here. We don't want to start in our middle in this case because, well, we don't want a solid there. We've gone to a lot of trouble to make a hole. We don't want to get rid of that hole. And I don't know how tall this is going to be yet, so let's just go ahead and bring it straight up a bit. Let's bring a flat piece over. This will be easier if I look at it straight on. Bring this guy over, and then we are going to make an arc. And again, we are going to go ahead, take our arc, and we're going to make it tangent using our tangent constraint here and tangent here. And you can see this has done some very funky things to our geometry. So we are going to undo that. I don't think we're going to manage to make this guy tangent. Yeah, no, that's not going to work. So we're going to redo this. We're going to delete. We could do this with the fillet tool, but I don't like to use the fillet tool if I don't have to. We're going to do 2 arcs. So remember, we're doing endpoint, endpoint, midpoint. Don't really care what it looks like right now. And then we're going to do the same thing. We're going to get our green dot. We're going to get our second green dot. Go like that. And you see it's already applied a tangent constraint. That is okay. I don't mind it already having done that. We are going to make this guy tangent to this guy. And then what we're going to do is we're going to make our 2 arcs tangent to each other. This is now playing a lot nicer. And now we get to do some sort of more arbitrary stuff. We're going to do dimension, and I will stop using hotkeys. I did just hit D to get dimension, but we will click the button instead. And let's go ahead and take this guy. Let's make this guy 2 millimeters. This is, again, entirely arbitrary. And then let's make this guy 24 millimeters. How does that look? That looks pretty okay to me. And we'll hit Finish Sketch. And we will now make our solids visible again. And we will now use our Revolve tool. Again, we get our closed area, our profile. We can select that. And then for our axis, we will select axis. Oh, and it's going to be grumpy at me. Normally, it would let us select this cylinder, but it's not doing that. So what we're instead going to do is we're going to pick the y-axis. It's invisible on our screen, but if we go over to the model browser, we can pick the y-axis. And now 360 degrees, joining. It wants us to select what solids we're going to join. We're going to join that guy. And now it will give us the preview. If we were to instead say new body, we wouldn't have to select what it's going to join. But we are saying join, and we are then going to select this guy. And we're going to hit OK. Now we have that. All right. It has brought these guys back into visibility, which I do not want. So let's make them invisible. And now, I mentioned before we have some issues with our geometry right here. That is a sign that this extrusion, we need to edit the sketch. Edit sketch. And so we want a different offset here. There's our offset dimension. It's hiding in a very inconvenient spot. Let's move it over. And we are going to make this guy be 2.4 millimeters. Now, why 2.4? I know that we have a 0.4 millimeter nozzle on our 3D printer. So I want this to be in multiples of that number, just so that we get just so it divides neatly. And now when we hit Finish Sketch, you will see it's going to update, and that little bit of geometry disappears. That is all good. One last thing that I like to do is we're going to combine, and we're going to make all these solids one solid. So we now have a single body. If we want to, we can get rid of this combine, and it'll go back to being multiple parts. Let's see, anything else that we can do while we're looking at this? Yeah, we're going to do a few little fillets for strength. Rather than having these sort of right angles, let's get rid of some of these guys. So we're just going to go through and... Sorry, let me actually walk through what I just did. I hit the fillet button. You've got some options here you can pick. I generally just do the normal fillet. You can also do chamfer. Chamfer tends to be stronger. We're doing this for strength. Let's do chamfer instead. And now you just go through and you sort of carefully select all of these edges. And just sort of orbiting around to get all these guys. Come on. And you'll notice it's slowing down a little bit. I don't have a great graphics card, so my computer tends to get grumpy. All right, it's a little bit ugly, but what happens if we select this guy? Yeah, that's what we want. So we've got all these little corners that we're selecting, just trying to get all of them. And this is one of the reasons that we wanted to join things together, is that if you don't have them joined, you can't chamfer them. And again, these chamfers give us a little bit more strength. I think that they look nicer, but that's not really our concern right now. All right, so we got those. Can I get this inside corner? Will it let me do that? It will let me do that. So we're going to get these inside corners, which are very finicky to get. There we go. And you can see, ooh, do I like that? No, you know what? Let's not get the inside corners. So we hold down, to undo these selections, we're going to hold down Control and then click, and then hold down Control and click. All right, let's not do those inside corners. And we will hit Apply. And it has applied our chamfers. That should give us a little bit of extra strength. Now we are actually done. Okay, one last thing. Let's take a look, and you'll notice that it has automatically updated in the assembly. And that's the nice thing about Inventor, is that as you update the parts, the assembly also updates. So we've taken a look at that, and we will now be done.